Okay, this is class number 6 for Math 12. Now, before we proceed with our new unit, just a review of the old unit and the work that you're supposed to be handing in. There's 3 hand-in assignments: mean, median, mode, and outliers from page 29 to page 34. 5 measures of central tendency from page 61 to 66. And then finally, analyzing percentiles from page 81 to 84. Those 3 assignments need to come in. They're all worth marks. All right, so just a reminder, now that we've wrapped up the last unit and we're starting a new one, this will be a brief class just to kick off our unit and do a couple of things. Once again, this unit will have 3 hand-in assignments. You will see the first one today. It's not very hard, short. It's only going to be like a 10-mark assignment. Very brief. So I want you to go to the first page of the print package that you have, the new print package. Module 8, precision measurement. You can see down here in the footer, Module 8, precision measurement. Module 8, cover assignment, puzzles in design. This unit, all about precision measurement, and different ways of using measurements and scale factors and so on. Drawing a diagram can sometimes be a useful strategy when solving a problem. It is usually necessary to draw a large object like a new home or office building much smaller than its actual size so that the drawing fits onto a page. On the other hand, sometimes enlargements are necessary. Commercial artists often make scale diagrams of logos and crests much larger than the actual objects so they can better illustrate fine details. These drawings, reductions and enlargements, are called scale diagrams. A scale diagram is usually demonstrated determined before the diagram is drawn. The scale is almost written as a ratio. Diagram size versus object size. Therefore, if the scale drawing of a ratio is 2 to 1, then the diagram is twice as large as the actual object. So diagram size always comes first and the actual object comes next. So this here is a reduction. The original drawing is bigger than the new drawing. So this was a reduction. Here we have, if a scale of a drawing is 1 to 5, the object is 5 times as large, so it's an enlargement. The original diagram, the new diagram is 5 times bigger than the original. So, reduction versus enlargement. The diagram number always comes first before the original. Whether the number is bigger or smaller depends on whether it's a reduction or enlargement. But in these ratios, diagram size on top, object size on the bottom. Page 8. Given the following object, enlarge it according to the scale 2 to 1. Here we have the original. It's confusing. I don't know why they did it this way, but hey. So if we look at this, 2 to 1. So this is the original drawing. It's supposed to be twice as big as the other one. So we're going to shrink this down. We're going to make this half. So the bottom here is going to be 2. And this is going to be 4. 2 and 2 because this is 4. So this becomes 2. And the peak from here, if we look, there's 3 squares. So that's going to be 1.5 squares up to the peak of your roof. Right there. just go across here and across here. Now the reason why I'm wondering about this is because this should not be an enlargement. This is 2 to 1. The original is 2 and the new drawing is 1. If it were an enlargement, then you should have 1, 2, not 2, 1. But they did an enlargement in their example. And I suppose we could have done the same, but that's not what the instructions are saying at all. Could do the circle, right? Their circle took up 4 squares, like that. Ours will just go something like 2 squares. Okay, so it should be a reduction. For some reason, they have an enlargement, as you can see here. But whatever, it's okay. You get the point, I think. Page 9. The 12 toothpicks activity. Example number 1. These 12 toothpicks form 4 small squares and 1 large square. Move 3 toothpicks to create only 3 squares that are all the same size. And I thought I brought some toothpicks, but I guess I did not. Just going to take a quick look out there and see if I can find something that can stand in place of these toothpicks. I think I have something here. No, I don't. There's only 8 of these leads. Hang on. Take a breather while I go take a quick look. If I don't find any, I guess we'll just do the example on paper here. Okay, I got something here. I'll take 12 of these guys. Four, 5, 6, 7, 10 now, 4, 10, 2 more. So let's make this diagram with the 12 toothpicks, same one that they made. 2 here. Kind of nice if the camera didn't continuously keep freezing up. Camera must have COVID-19. So there we have 4 squares, 4 small squares. We want to move just 3 toothpicks to create only 3 squares that are all the same size. So, which toothpicks do we move? These here. And this one here. And where are these new toothpicks gonna be? Down here. So now we have 3 squares up top, middle, here. This is not a square because it's missing a side. So we have effectively created 3 squares that are all the same size. Simple exercise, right? Let's have a look at the hand-in assignment, page 11 to 14. I'm going to clean these up first. Otherwise I'll be losing them. Slip them back into the electrical kit. So, page 11 to 14. As I said, this is not going to be a very long class. It should be done in less than 20 minutes. So, this is a 10-mark assignment, beginning on page 11. Draw a scale diagram of each object according to the given scale, 1 to 3. So, okay, I feel like I'm confused here. Like I wouldn't have thought that this should be a reduction. Okay, I got it. There's the original. So what you're going to do here? You're going to do a reduction. There wouldn't even be enough room to do an enlargement. I mean, if you're going to triple this, but no. You're going to divide it, take each side, divide by, like this side here is a 6, so it would become a 2, and so on. Okay? So you're going to make a reduction of this shape here. Page 12, 2.5 to 1. Now you're going to make an enlargement that's 2.5 times bigger. So each side of this square is 5. So to get your new number, to get the lengths of your new square, you're going to have to do 5 times 2.5, right? To get, that's your new. And same thing with this. Here you're going to take the diameter of the circle and make it 2.5 times longer than it is. I would do the triangle in the middle first, then I'd worry about the circle. But anyways, you're making the shape 2.5, 2.5 times bigger. And the grid for this is on the other page there. Draw a floor plan for a bathroom with measurements 6 feet by 9 feet and the following requirements. So you're going to make your bathroom as a 6 by 9 rectangle, and your bathtub 2x6, your sink 2x3, your toilet 2x2, and the door should be a 3-foot opening. Be sure to allow enough clearance for the doorway and walkways around the fixtures. Also, note the scale that you used. So you're probably not going to take, there's the grid paper on page 13. You're probably not just going to make a 6x9 rectangle. You'd be dealing with a very small, right? I would say you're going to enlarge that. So pretend that each of those squares is the side of each of these squares is a foot, for instance, and enlarge it. You could say that 2 squares equals 1 foot. So then the side that's a 6 would become a 12. And the side that's a 9 would become an 18, right? You see what I'm saying? So 2 of these squares could represent 1 foot. And you would do the same thing when you're doing everything else. Second part of the assignment. So that all is 5 marks. The 2 scale drawings and the bathroom scale drawing, 5 marks altogether. These 9 toothpicks form 3 triangles. Move 3 of these to create 5 triangles. So once you figure out what to do, just sketch a new diagram showing what you did. Same thing here. 9 toothpicks, 4 small triangles and 1 large one. Remove 2 to leave 2 triangles. And again, just show what you did. I could remove just 1 and get 2 triangles. If you take this guy out, then you effectively have a parallelogram here. And there's 2 triangles left. There's this one and this one. Take that one out as a parallelogram, and these 2 are left. Oh, I guess you've still got the big triangle there. Even though you take that one out, you've still got the big one. So you'd have to do a little more, but you get the idea. 12 toothpicks. Move 4 toothpicks to create 5 squares. Again, figure it out, make a sketch to show what you did. So this is your first hand-in assignment. Scale factors. It's straightforward. Don't get confused like I did. It's easy stuff. I'm not sure even why I did get confused about some of that stuff, but it's fine. You'll be okay. You're probably better at this kind of stuff than I am, if I'm being completely honest. So we can shut down the recording at 18.